Hello guys, this is Paul McWhorter from TopTechBoy.com, and we are here today with episode number 35 in our live Shop Talk series. Yes, we are live, and we have an exciting program for you today. At least I hope you are excited by this program, because what we're going to talk about today is a very important programming concept, and it's one that's a little bit confusing, but I want to try to see if I can clear it up for you. Those of you who are following along on our robotics tutorial, we sort of ran into this issue in the last few lessons on that episode, and so I didn't feel like I really explained it very well, and so I want to go over it today because it's something that's important not just in that particular application, but in almost anything that you're going to try to do. You need to understand the difference between blocking functions or blocking operations versus non-blocking operations, okay? And so I'm going to try to, it's like when you try to understand this, it can be a little bit confusing. And so I want to do kind of like a really, what I would say is a simple demonstration that will help you understand this. And so what we are going to do is we are going to go to our old friend, the Arduino, and I'm going to get out of your way and see if I can show you the difference between blocking and non-blocking. So let's start out by writing a really simple Blink program. Don't want to bore you with building the circuit, but you can see that I have above me here, I have a red and a yellow LED. So let's see if we can write a really simple program to blink that red LED. Okay, so we're going to come up here and we'll need to set up a pin. It will be red LED, and that is connected to pin 6, I do believe. Okay, and then if we're going to blink the red LED, we need to come down and do our pin mode like that. Pin mode, what do we want to do? Red LED, and what is it? It's an output, and then we go like that, and then we come down here in the void loop, and let's just say that we do a digital write of red LED, and we're going to go high. Okay, and then we are going to do a delay of 500, a delay of 500 milliseconds, and then we will do a digital write of red LED low. Okay, and then we'll wait, delay 500. All right, I really want this to work without a mistake, so it's such a simple program. Let's see if we could do it. Yes. Oh, red LED. Oh, I forgot to put in. That was a rookie mistake. Were you guys yelling at me? I didn't declare it up there. Okay, let's see if this is going to work, and let's see if you can see it. Looks like it's going to compile. There it goes. Okay, you see the red LED blinking? Boom. Fairly straightforward. On for half a second, off for half a second. And let's just say we wanted to have it on for a second, off for a second. We could go 1,000 and 1,000 like that. This is really simple stuff, right? Hey, I forgot to tell you guys to pour yourself coffee, okay? I was sort of conversing with you guys on the chat right up. I was conversing with you guys on the chat right up until the time I launched this, and so I didn't get a really smooth launch on this. But we'll recover. Okay, so now you can see that the LED is on for a second, off for a second, on for a second, off for a second. All right, simple enough. But hey, what about this? What if we wanted to blink the red LED and the yellow LED at the same time? Well, I think I could do that. I could come in and I could create another variable called int yellow LED. Okay, and that's going to be connected to pin 5 just because that's what I already did when I hooked the circuit up, so I'll just tell you that. Then we can come in and we can do digital write, okay, and yellow LED, and it's going to be high. All right, and then we are going to add, I think I can just probably copy this like this, come down and paste. All right, and now it should blink the 2 LEDs when we do this, right? This is pretty simple stuff. Hey, Philippe. Wow, man. Super chat from Philippe. Really appreciate that. You know, all these little super chats you're giving, Philippe, that's going into my coffee fund. And I treat myself to special coffees thanks to Philippe. Really appreciate it. Really, really appreciate it. Okay, let's see. That did not work. What did I do wrong there? Digital right LED high. Oh, I forgot. It should be digital right LED low like that. So now let's try it like this. I am really perplexed why I thought I downloaded that. Okay, what am I doing wrong? Yellow LED. Tell me what I did wrong. Pin mode. GMNERC. Yes, pin mode. Pin mode. You guys, that scared me on such a simple program and it didn't work. I was a little bit scared there. All right, I really hope this works because it's kind of hard to do these things live, you know. It's a little scary. Okay, there it goes. Boom. I got to tell you, I was scared there because I didn't know why that wasn't working, but it was the pin mode. Okay, so we've got the red LED and the yellow LED blinking together. All right, so how, hey, Opal, welcome. It's always good to see one of our old regulars, and big boggy face, Matt. Let's see, Jim, Baybar. Okay, so we got a bunch of people coming on here. All right, so that's pretty straightforward, right? I can blink them together. All right, but now I'm going to tell you something that sounds really easy. Okay, I want you to blink the red LED for 1 second on, 1 second off, and then I want you to be blinking the yellow LED at a 1/10 of a second on, 1/10 of a second off. So I want the red LED to blink slow, and I want the yellow LED to blink fast. All right. So you guys go ahead and start writing comments if you think you see a problem there. But what I'm gonna do is, how would you kind of think about doing this? Well, maybe you would want to take this and say you're gonna cut that. Okay, and then I'll come down here and paste it. Okay, and then I would do a delay. Can you guys see that? Yeah, a delay of 100. All right, and then I will take this one and cut it. Okay, and I'll put it here, and then I will say delay 100. All right, and so the red LED is going to be blinking slow and the yellow LED is going to be blinking fast, right? Because I have the delay of 100 on the yellow and 1,000 on the red. So let's see what happens. Okay, do you see what the problem is? Do you guys see what the problem is? The red is blinking slow and then the yellow blinks fast, but they're not blinking at the same time. And why is it that they are not blinking at the same time? The reason that they are not blinking at the same time is that this delay function is what you would call blocking. And so this seems so obvious that you wouldn't even have to explain it, but it turns out to be a pretty hard problem. So what do I do? And this also helps you think how a program actually works. It does one line of code at a time, and it doesn't go to the next line of code until it finishes the line of code that it's on. So let's think about what happens. The red LED is turned on, and then you wait 1 second. That means that you're sitting at this line of code for 1 second. Okay, you are sitting at this line of code for 1 second, and then you turn the red LED off, and then you sit at this line of code for 1 second. So do you see what the problem is? Is that while I am waiting on the red LED on, the yellow one can't be turning on and off because the Arduino does not have threading. You can only run one thread at a time. And so when you are waiting in this line or waiting in this line, you are blocking anything else from happening. Okay, you are blocking anything else from happening. Okay, so how would we deal with this? All right, so I see Dan is suggesting an interrupt. Yeah, okay, so you could do some interrupts, but I'll be honest with you, there's some hardware interrupts on the Arduino, but the software interrupts are a little bit hard to configure, and also it's like I think you've got to install some libraries to get the software interrupts going. And so if you really had robust and simple interrupts, you could do it with interrupts. But how could we do this? How could we do this without interrupts? Okay, how could we turn this blocking function into a non-blocking operation or non-blocking function? Let's see if you guys have any suggestion. Dan, yeah, interrupts would be a great way to do it, but I want to see if we can think about doing this. Okay, Jim is saying do a loop within a loop. The problem is if you're still blocking in that inner loop, that I can't be running two loops at the same time. That is blocking. Threads are not available. While loops, a counter. Okay. We've got some different suggestions. All right, I'm not exactly sure what you guys are thinking, so let me show you kind of a way that you can do it. All right, and so I'm just going to try to step you through it. So I'm going to take all this nonsense out, and up here what we're going to need is we are going to need some additional variables, and I'll try to kind of explain them as I go. First of all, I need to kind of keep track of what is the blink time. So I'm going to have a red blink, and I'm going to set red blink equal to 1000, just so I'm using a variable here. Okay, and then I'm going to have yellow blink, and I better put my int in there, int yellow blink. Okay, and I'm going to put that for 100 because I want that to be quicker. All right, I think what I'll do is I'll just see if I can blink the red in a non-blocking fashion, and then we can come back and we can blink the yellow on top of it. But let's just see if we can make it work to blink the red without doing a delay. Okay, so I'm gonna just start putting the red variables in. So what I really need is I really need another variable called red timer. And what red timer is going to keep track of, red timer is going to keep track of how long, it's going to kind of help you keep track of how long the red has been on or off. Okay, it's going to help you keep track of how long the red has been on or off. And so what I'll come down here is I'm going to come down into the void setup, and what I'm going to do is I am going to go ahead in the void setup and I am going to turn the red LED on. So I'm going to say digital write, and what am I going to digital write? I'm going to digital write the red LED. Okay, and then I'm going to make it high, so I'm going to turn it on, and then now I'm going to capture the time that I turned it on. And so I'm going to do that by saying red timer, okay, is equal to Millies. And Millies just gets the present system clock. It's like how many milliseconds has the Arduino been running since you started the program. And so I've kind of grabbed a marker in time of when the red LED went on. When did it go on? It went on at red timer. Okay, now I've got to actually keep track of how long it has been on. So I need another variable, and I'm going to call it red on. Okay, and red on will keep track of how long the red LED has been on. So when I come down into this variable, when I come down into this void loop, what I'm going to do is I'm going to say red on. How long has red been on? Well, it's been on for Millies. Okay, the present system clock minus what? Red timer. Okay. And so that's going to keep track of how long it has been on. So if I just sat and ran this, it's going to keep running, right? It's going to keep running, and then read on is going to keep track of how long it has been on. Well, I'm going to need another variable, and I better keep track of whether the read is on or not. And so I'm going to need another variable up here, and it's going to be int, and it's going to be, let's just call it is read on. And instead of an int, I'm going to make it a bool. And what that just means is it's a variable that's either 1 or 0, high or low, on or off. Okay, it's just a binary variable. So I'm going to say bool is read on. Well, I turn it on at the start, so I'm going to go ahead and set it to true, right? Because when I get right here, it's going to be on. So I'm going to go ahead and set is read on to true. Okay, and I'll come in and I'll do the yellows later. I will do the yellows later. Okay, so now what could I do down here? So this is going to keep track of how long red was on. So what I could do is I could say if the variable read on is greater than or equal to red blink. And what was red blink? Red blink was how long I want it to be on. So if read on gets equal to red blink, what do you think I want to do? Okay, what do you think that I want to do at that point? What I will want to do is I will want to switch it. Now, if you just thought, you might be thinking, well, let's just do a digital write low. Well, that would work to leave it on for a second and then turn it off. But the problem is you don't want to really turn it off. You want to switch it. If it's on, you want to go off. And if it's off, you want to go on. And so what you've got to do is you've got to say is read on. That's right, the Boolean either true or false. Well, right now it's true. Well, what you want to do is make it the opposite. So you want to say is read on. You make it not of is read on. So if is read on is true, then it's going to, if read on is true, then it's going to become false. If is read on is false, then this is going to switch it to true. So wherever it is, it's going to switch it to the other one. Okay. And then what do I want to do? Well, I want to switch the light. So I will say digital write red LED. Okay. And then I want to just write it with is read on. Okay. And so do you see what this is going to do? If is read on is true, the light is on, it's going to make it false, and then it's going to write a false to it's going to digital write a false to red LED. It's going to turn it off. If it's off, is read on is going to be false. This will make it true, and then I do a digital write to red LED of true, and it's going to turn it on. Are you all totally confused by this? Is this totally confusing? I hope it's not. Okay, now the other thing is, what you got to see now is you've got to, what else do I need to do? There's something else I need to do in this if statement. Hey, somebody says you're not confused. Great. And Hassan from Tunisia, welcome, man, welcome. And we've got Aksh from India, welcome. Okay, and we've got a few people that are very confused. Okay, so we will go over it a little bit more, but somebody tell me what I need to still do in this if statement. What is something that still needs to be done in this if statement? If I just did this, what would it do? Okay, it would work one time. No, I don't ever use else ifs. I don't use else's. Okay, nobody's telling me what I need to do in this if statement to make it really work. Okay, I'll give you a hint. It has to do with timing. Somebody tell me what I need to do with timing. Okay, I am not getting any good suggestions, so I will just go on. What you got to see is, yeah, I've got to reset the time. Okay, I've got to reset the time because red on is keeping track of how long it was on. Well, when I switch it, what do I need to do? I need to go out and I need to grab yellow time. I need to grab red timer again, and I need to say that it is equal to Millies because that is when I switched it. So I grab the system time of when I switched it, and then when I come on and I look at red on again, it's going to be going the amount of time that has elapsed since red timer. Okay, LJ asks, what are we trying to achieve? We're trying to achieve a non-blocking way of operating the LEDs. And so I want the LED on for a second, off for a second, but I want the yellow LED to at the same time be switching very quickly. So then red timer is going to reset to the new Millies. And so now the yellow is still not going to work, but at least this should be a non-blocking way of doing. I think this should be a non-blocking way of doing the red blink. And so let's come in and let's do this and see. I hope I declared all my variables. Okay, I forgot somewhere in here. Forgot my semicolon. Hopefully you guys were yelling at me. Let's try now. Okay, boom. Do you see what I am doing? I am blinking the red LED without using delay, because delay would block the whole thing. Okay, delay would block the whole thing. All right. So now, okay, let's see. Got an interesting suggestion from Keith. I toggle by doing digital right LED, not digital. Yeah, that's actually a smart thing, Keith, and I know exactly what you're doing. It's just this lesson's already kind of confusing, so I didn't want to get too clever, and I just wanted to do kind of more easy to understand ways of blinking. Okay, so what sets the rate? Well, what sets the rate is where I set red blink up here, right? I set red blink to 1,000, and then I compare how long I've been in the present state to red blink. And if it's more than what red blink is supposed to be, then it switches it. Okay, if it's more than what red blink is supposed to be, it switches it. Okay, now what do I need to do to get the yellow LED to blink fast? Okay, do you see that I'm blinking the red LED without blocking? There's none of these commands that will lock the Arduino up. It's going to go through them very quickly. What do I need now to make the yellow LED work? I'm not getting suggestions from you guys. Maybe my latency is longer than what I thought. I'll give you a few seconds to make a suggestion of now how do I get the yellow LED to blink quickly. 5, okay. Use the same code and change the yellow. Yeah, what I think you really need to say is you need to say, let's take this if statement. Okay, and it's going to be a new if statement. So I'm constantly going through the main void loop, but now I'm going to look on yellow, and I'm going to look on yellow, and I'm going to have to declare these variables up at the top again. Yellow, and is yellow on, digital right yellow, and is yellow, and then it's going to be here yellow timer. All right, and now up here where I do red on, I also need to do yellow on, and that's going to be equal to Millies minus yellow timer. All right, now what I will need to do here is I will need to yellow timer is equal to Millies. So I initialize that timer right there. And now I got to do some variables up here. Okay, I did my yellow LED pin mode. So I've got if red LED is 6, yellow LED is 5, red blink is 1,000, yellow blink is 100. I've got red timer. I need yellow timer like that. And then if I'm keeping track of how long red is on, I need to keep track of how long yellow is on, and then I will also need to keep track of whether yellow is on or not, so I'll use the Boolean is yellow on equal true. Okay. All right, let's see if this works. Okay, Benji, I'll give you a shout out, but you gotta stop repeating yourself. Okay, what's the issue with? Okay, I'll get back to that in a minute. Let's look. Okay, boom. Do you guys see that? The red is blinking so slow. The red is blinking slow, and the yellow is blinking fast at the same time. Non-blocking. Boom. Okay. I hope you guys understand how important this is. And it looked like from the comments that a few of you guys were kind of confused. And so like you can turn red on and you can delay and then turn red off and delay. But the problem with that is during that delay, you've blocked execution of any code. And so we are doing it different. We keep track of how long red has been in its present state with red on. That's the present clock minus where the clock started. Okay. Now, if it has been on greater than or equal to the blink time, which we set up here, if it has been on longer than that, then what do we want to do? We want to switch it. And so what we do is we do a digital write of the red LED to is red on. But what we do is we make is red on the opposite of what it was before. All right. And so if it was off, it's going to make it on. If it was on, it's going to make it off. And then what we have to do is we have to reset the timer because it's switched. Now we've got to start counting the time again. Okay. And so this is a way that you can do things in a non-blocking function, in a non-blocking fashion. Okay, I hope this makes sense to you guys. Let's see if we have some comments here. Let's see. Opal gets it. All right. Ohio Tech Team. Hey, Ohio, where have you been? I haven't heard from you in a while. Welcome. Glad you were able to join us. How many timers can you have running at the same time? Well, you can have kind of as many as you want if you do it the way that I'm doing it here. But at some point, what will happen, those little microseconds it takes to execute a line of code could start affecting your timing. But for non-critical timing, this really is going to work for a lot of different applications. Okay, let's see. When will Millies get overflow, hit the maximum value? Okay, there is an issue with the Millies function. There is some maximum amount of time that it will work, but there are some ways around that. One of the things is, one of the ways I can, before the Millies is going to overflow, this int red timer is going to overflow. So I think that ints are limited to like 32,000 or something like that. And so if you tried to do more than a 32-second delay using this, you would run into a problem. But you could make this a long int or a long unsigned int or one of those variables. It could make it a lot longer, and that would take care of it. Okay, let's see. Ghost Dog, hello from the UK. Hello. Don't we have a thread here? I don't know how to do threading in the Arduino. I don't know if there is a way to do threading in the Arduino. You could do that on the Raspberry Pi in Python, but I don't know of any way that you could do it. If they run on separate cores, does delay still cause a block? Not sure I completely understand that. Yes, Millies. Okay, Millies is not a timer. Millies tells you what the current system clock is, and that's like the number of milliseconds since the program started running. Okay, so it's like Millies goes out and grabs the system time, if that makes sense. Okay, it grabs the system time, if that makes sense. This is special. We should use a blue LED. Brady, man, if I would have been thinking, I would have used the blue LED. But you might see that I had kind of a SparkFun kit. I had one of my old SparkFun kits, and I just grabbed parts out of there. If I'd had my Elegoo kit handy, maybe I should have used a blue LED for the indeed special occasions. Okay, let's see. I don't understand how that is working. Why not a counter? Well, kind of we're doing a counter, but if you just said, like, I'm not sure how you would do it with a counter, because what we want is we want it on for a certain amount of time, not on for a certain number of trips through the loop. So I would not really know how to do it with a counter. Let's see, I will try and share code with you, sir, if I am successful. Okay, that sounds good. For the first time, I saw another form of programming that did not interfere with work. Okay, thanks for the response. Yes, Blue is special episode. When you give power to Arduino, it starts counting milliseconds, and the Millies gives you the current count. Okay, very good. What are we building? We are building something where one LED is blinking fast and the other is blinking slow. It's harder than you might think. Those spark funds have nice 90-degree pattern. Okay. I watched you do this same question using the Timer 1 software interrupt. I understand there are many ways to skin a cat. Yeah, okay. You can do it with timer interrupts. It's just explaining interrupts is a little bit more complicated than what I wanted to do today. And I believe the last time I fooled with the Arduino and interrupts, you had to install libraries to do software interrupts. And it's fairly easy to do hardware interrupts, but software interrupts, the last time I checked, required installation of some additional libraries, and also using timers seems to break the Millies function as well. Okay, I want you to do this same operation using the Timer 1 software interrupt. I understand there are many ways to skin a cat. Okay, I hooked up now. Are you using interrupts? No. The issue is I'm showing you how to do it using one main void loop without having to use interrupts and with it being non-blocking. Okay, guys, do you understand now the difference between blocking and non-blocking? And we sort of ran into this in our smart car project, to where, like, if you want the car to go 10 feet, you would like turn the car on for 10 seconds. But then if you put something in front of it and it stopped to not hit it, then when you removed it, it's not going to go far enough because it kept counting while it was blocked by the obstruction. And so we had to kind of do something like this in that lesson to get the car to go the right amount of distance, independent of how long there was an obstruction in front of it. And I kind of went through it, but I think some of you guys were confused, and so I wanted to go through it here so you guys would sort of better understand in a really simple example of the difference between blocking and non-blocking, and how, if you think through things, you can use normal code to create non-blocking operations. So you guys give me some feedback. Does this make sense, what we were trying to do there? So is there ever a reason to use the blocking or delay, or is it only for small programs? I try to do things in a non-blocking fashion because maybe you don't think about the smart car. When we started the smart car, we just used delays because we thought we don't have to worry about blocking or non-blocking. Then when we get to the thing of wanting it to stop if there is an obstruction in front of it, now all of a sudden the fact that we were doing it in a blocking fashion meant that we had to kind of start over and do it over. So I always like to try to do things in a non-blocking function, in a non-blocking fashion. Now when you get to things like doing RSTP or RDP or UDP, or kind of like Ethernet type communications, or maybe even some USB type communications, this blocking or non-blocking can become very, very important, because if you're sitting and waiting for data, then the rest of the code isn't executing. And so it's really something that, even though this is a really simple example that I've given here, it's really, really important, and it's something you guys need to really understand. So give me some feedback. Did this make sense? Danny says, thank you. Well, Danny, thank you for tuning in. I'm knocked down. So I always like to use non-blocking. Big boggy face, is there other things that create blocks other than delays? Yeah. Anything that, like, imagine imagine that you went to read something and there was nothing there, it's going to sit and wait until there was something to read. So there's a lot of things that can end up being blocking. If I go out to try to grab data from the sensor and the sensor hasn't sent it yet, that can be blocking. So there really is a lot of stuff that can be blocking. Hey, Dennis says it makes perfect sense. Thanks, Dennis. I'm glad somebody understands it. When are we getting more lessons on the robotic videos? Hey, Devin, I've been giving you one a week, right, man? I've tried to, I think for the last 3 weeks, I've given you one a week. I'm going to try to get one made this week or next week, if not. Okay. Yeah, I would pretty much use this instead of delays. Can you do Arduino Python for the smart card that you did for the IMU BN0055? Well, I would have to think about where is Python going to be running, right? Where would you be running Python? Because the Arduino doesn't run Python, so I'm not sure exactly what configuration would do this. Okay, Peter says it makes sense. Hey, Devin, man. Wow. Devin, thank you. 2 super chats today. Guys, that's really an encouragement for me, and I really do appreciate it. And also, you know, guys, I really want to give you guys that are helping me out over at Patreon a shout out too. I have just ordered some exciting new studio gear, and maybe next week I could kind of share with you guys where I've kind of taken some of the you know, that Patreon support you've been giving me and pouring it back into the studio. I will be getting a new camera, a new computer, some new capture boards. Now I think I've gotten to where my studio has been in pretty good shape and I'm getting some pretty good production quality. But there's some problems with the equipment that I have. My camera is about 8 years old and the battery is dead on it. And so if I lose power, I have to go in with menus and completely reprogram the camera, which is really a bummer. Also, I don't have the bandwidth that I need, like the USB bandwidth that I need on the computer. And so sometimes my mouth gets out of sync with my voice. And there's sort of an audio video syncing problem that I've traced back to the bandwidth of the computer that I'm using, the USB bandwidth. And so I will be getting a new computer, a new state-of-the-art camera, a new state-of-the-art HDMI capture board, and I think it's going to allow me to crank out some much better videos. So again, just really appreciate you guys. Okay, William, sorry to change the subject, but can you tell me what happened to Jetson Nano lesson 49, loading necessary libraries, searching the site, doesn't find it? Okay, I don't off the top of my head know what Jetson Nano lesson number 49 is, but I will tell you what the challenge is on the Jetson Nano and the Jetson Xavier series. I go in and I make like 60 lessons or whatever, and then I release them once a week, and then all of a sudden there's a new version of Jetpack, there's a new version of OpenCV, there's a new version of CUDA, there's a new version of PyTorch, there's a new version of dlib, and then all of a sudden my series of lessons don't work unless you are using exactly the same versions of the software. And so what you have to make sure is, if you want those lessons to work on the Jetson Nano, you need to be using my version of Jetpack, which on the Jetson Nano was Jetpack 4.2. And if you do that and you go through all the lessons on Jetpack 4.2, it will work. But if you just go in today and download Jetpack, you're probably getting Jetpack 4.4 that doesn't have the same versions of PyTorch and all of those different things that I was using. And so all of a sudden those things break. So what frustrates me is that last year I spent about 90% of my time on the Jetson Nano lessons and on the Jetson Xavier lessons. And then by the time I release all the videos, already things are starting to break. And so I am not sure exactly how to move forward in a manner that we can get good instructional quality videos built, like a class built in an environment where the versions of the software are changing very quickly. Okay, yeah, it's a good upgrade to upgrade the studio. Can we get a video on DMA? I don't know what DMA is, so you'll have to tell me what DMA is. Maybe if you tell me what that's an acronym for, I would understand it better. Here's a menu library you need to look at. Arduino, I'm not sure Arduino. I'm not sure what that is. Okay, got a lot of comments coming in. How to avoid blocking of long sensor read times. Well, I think that you've got to look at what it is. Like on the Adafruit GPS, that is constantly streaming data, and so you kind of got a similar problem there. And so you've just got to think through things, and you got to do things in such a way that it is not blocking. NVIDIA, they keep upgrading rapidly. Yeah, I love NVIDIA, and they're really great people, but the problem is that their hardware platforms are changing, their jetpacks are changing, everything is changing. And for a guy like me that wants to build instructional material, it's hard for me to build 60 lessons and then have them obsolete before I've even released them. You know, guys, I'm having a similar problem with Fusion 360. I made a really good set of lessons on Fusion 360s, and then they keep changing the user interface, and I wish they would stop changing that. Because while they're making trivial little changes to the Fusion 360 interface, it is breaking my lessons. Now, I am thinking about going in and redoing my Learn Fusion 360 or Die Trying series of lessons, because those are probably 3 or 4 years old now, and the user interface has changed enough that those have become somewhat broken. So I've got Christmas break coming up. I'll have 2 weeks to make a new video series. I'm thinking about maybe redoing the Fusion 360 lessons. I'm thinking about maybe doing a lot of lessons on the Elegoo Smart Car. I'm thinking about maybe just doing a series of lessons on calculus for engineers. You know, calculus is really easy if you understand it. So I thought about kind of doing a calculus series, thought about doing a digital logic series where we go in and really get into Boolean algebra and digital logic and doing a class on that. So you guys give me some feedback here. What do you think that I should do with my 2 weeks over Christmas to make a really good set of instructional material? What would you guys like to see? Okay, some Fusion 360 calculus and digital logic would be cool. Okay, Philippe, I think it would be calculus or digital logic, because in 2 weeks I could probably put together a really nice calculus class or a really nice digital logic class. But if I'm really rolling, I can maybe do 2 video productions a day. And so if I had, let's say, 6 days a week, that's 12 days, I could do 24 lessons. That would be a pretty nice calculus class, or that would be a pretty nice digital logic class. But both would be kind of hard. Calculus basics, calculus, hey, you've got some interesting calculus here. I don't know, Mike, you tell me. The last I looked, there was a home hobbyist version of Fusion 360 that was full, kind of like full featured. If that has changed, let me know, because if they're not giving you a free home hobbyist version of Fusion 360, there is no reason for me to waste my time in trying to teach it to you. Okay, drones with robotic arms and... Okay, I will not be doing a drone series, because a drone is a flying blender. And you want me to teach you how to program a flying blender that you then fly into your neighbor's face and then come blame me for it? I'm not going anywhere near anything associated with drones. Okay, Danny says just be interested in whatever I'm doing. All right, so... sounds like maybe a lot of interest in calculus, maybe calculus or redoing the Fusion 360 lessons. I've also always kind of thought about maybe kind of doing a series of lessons on the Raspberry Pi Zero. It's, kind of like a Linux machine that'll run Python. Kind of thinking about maybe doing that as well, but we'll have to sort of see where that goes, because what I'd really like to do, I'd really like to do calculus, okay? Because I understand calculus and it's really, really simple and I can explain it to you. So if you guys are interested, maybe I would do a calculus class. What I'd like to do though is it would be great if I could somehow like tie calculus to Arduino, where we're going through an Arduino problem and then we're solving the Arduino problem using calculus. Something like that might really be interesting. Although Santiago is asking for digital logic, a robotic arm. I have a robotic arm, but I don't know. It's so hard to get a robot to really do something. It's so hard to get a robot to really do something. Okay. Calculus and Arduino, got some interest there. Fourier series and signal transforms. I love the math behind Fourier transforms and Laplace transforms, but I'm just really not sure of a good demo project to do with it that really Fourier transforms and Laplace transforms get into signal processing, and I can't off the top of my head think of a really interesting signal that we could do that would make it interesting and fun. Okay, Newman is finding my tutorials useful. That's good. It would be simple if you use calculus in Arduino. Okay. All right, hey man, maybe I'll do some calculus. The challenge is going to be, I want to give you like a real problem, and then the calculus becomes interest. Like, remember all the linear equations we did in the Arduino series of tutorials? I think a bunch of you guys for the first time saw why you need to understand lines, because it solved problems that let you do cool things on the Arduino. I want to see if I can come up with a similar type of problem that we could solve using calculus, where you would need calculus, because man, calculus is so fun and it's so exciting and it's so interesting and it really makes sense. The problem is I think most calculus teachers don't understand calculus and they're just showing you steps and you're following the steps. I had a young lady who was a very good calculus student. I mean, she really, she went through 4 years of math with me, and she got to the University of Texas and she got there like 2 weeks into the class. She wrote me and she said, you know, I'm taking calculus here, but my calculus professor doesn't understand calculus. And she tries to explain it, but it's like she doesn't know what she's talking about. And this girl got an A in the class because she really understood it, but everybody was struggling because the calculus teacher really didn't understand it. The calculus teacher knew how to do steps and show steps, but didn't understand the beauty and the elegance of what calculus really is. Okay. Let's see. Guys, we have been going for about 45 minutes here, and my coffee is getting cold. And so instead of just rambling on, perhaps I should just wrap this thing up. I think maybe next week I'll show you guys some of the cool stuff that I've gotten and I'm putting together for the new studio. And I kind of want to do that to give a shout out to you guys who have been helping me out either with the super chats or with the Patreon, kind of show you how I'm trying to invest that money back into the quality of what I am producing. And then maybe right now I am leaning towards over Christmas putting together a series of lessons to teach you calculus, maybe calculus for engineers, and then I would release those videos once per week. And then I do want to continue with the Elegoo Smart Car Kit. I know a lot of you guys really want me to do the JetBot series, okay, but I just don't have the bandwidth right now to do that, as I am continuing to work full-time, and you know, it's very hard to be teaching in a public school with the pandemic thing going on, and so things that used to be easy are hard, so I just don't have time during the week to be making videos. And then on the weekend, right, I'm doing a live stream, and then there's some other stuff that I'm doing, and so it's hard for me to bite off on a project like the JetBot right now. But I am going to do it, but it will be after I kind of wrap up my teaching career, kind of leave my permanent full-time employment. Okay guys, Really appreciate you guys tuning in. It's a big encouragement for me to have you guys join me on Saturday. I have a lot of fun with these. I hope you guys enjoy them as much as I do. Really appreciate if you guys would give me a thumbs up and leave a comment down below. A thumbs up and a comment helps me with the YouTube algorithms, helps get my videos out there and seen, helps us continue to grow this channel. If you really want to help out, share this on your social media, share my channel on your social media. Let's see if we can get more subscribers and more viewers, because that helps me build momentum towards that day that I'm really looking forward to, of retiring from my permanent full-time job and being able to do YouTube full-time. Okay, guys, I am going to go ahead and let you go. Paul McWhorter from TopTechBoy.com. I will talk to you guys later.